This is a continuation of a problem we started earlier where we found the initial velocity. So this is listed here as an unknown, but it's now known to be 44 meters per second upward. And I had drawn in the downward portion of the motion because it fell and was caught. But we're not interested in that part. We're only trying to analyze the upward portion right now. We're trying to find its peak height and how long it took for it to reach its peak height. So during this time, we know that the acceleration is equal to negative 9.8 meters per second squared. And we don't know how long that's going to take. It takes 5 seconds for it to go up and then part of the way back down. It doesn't get caught at the same height. We know it's going to be some number less than 5 seconds. And we also are interested in finding y. So let's see, how long? Let's find t, and that should be a positive number. Have units of seconds. We're going to find y. It's going to be a positive number and have units of meters. When we think about the equations of motion, like x equals x naught plus v naught. Oh, I started thinking about this in terms of x, but this problem is a vertical problem, so it's y. So I'll just erase that and start over. So the equation, of course, is y equals y naught plus v naught yt plus 1/2 ay t squared. So that's one of our equations. We only have 4 equations on there for the vertical direction, so just pick one of them and go with it. We don't know this. We know that. We know that. We didn't know it originally, but when we solved part A, then we figured that out. We don't know that. We do know that. We don't know the time. So we have 2 unknowns in there, so we're not going to be able to solve that. But if we could get the time, which we have to do anyway, then we'll be able to solve that for y. And then we think about some of our other equations. For example, Vy equals V naught y plus Ayt. We don't know the time, that's what we're looking for, but we know the acceleration, we know how fast it was going when it started, and we know how fast it's going at the peak. By definition, when it gets to its peak, its velocity is 0 meters per second. So that's our plan, is we're going to solve this first. Okay, that'll be step 1, and then that'll be step 2. So we'll come down here, and we substitute in 0 equals 44 meters per second minus 9.8 meters per second squared times t. And then we could add 9.8 to both sides. 9.8 meters per second squared t to both sides. And get this. And then we can divide both sides by 9.8. And we get a value of 4.49 seconds. And that's less than 5 seconds, which we expected. Another thing that I didn't talk about is it's more than 2.5 seconds. Because if it came out to be, say, 2.4 seconds, that would mean it's going down for 2.6, and that wouldn't make any sense. We know the downward portion is going to take less time than the upward portion. So this is perfectly logical. Now we can substitute that value in. We know that y equals 0 plus 44 meters per second times 4.49 meters per second minus, plus 1/2 times negative 9.8 meters per second squared times 4.49 seconds quantity squared. And we take a look at our units. We're going to get seconds squared here, and this is meters per second squared, so that's going to come out to a unit of meter. Here we have meters per second times meters per second, and that's going to give us a unit of meters squared per second squared. But if we look, that's because we wrote, well, I wrote in the unit incorrectly. It should just be meters. It should just be seconds. So meters per second times 4.49 seconds. And so that will give us the correct units of meters. And so we plug that into our calculator. and we get a value of 98.8 meters. Is the solution complete? Yes, we solved for both the time and the max height. The signs make sense. We expected positive numbers for both of those. They had the right units. The magnitudes are reasonable. We already talked about the time, and this, it's going up 300 feet roughly, because there's about 3 feet in a meter. So 3 times 100. 300 feet is a really high height for a ball to go, but like I said in the last video, it's going at about 100 miles per hour, so that makes sense. It fits in with that. If somebody could throw it that fast upward, it makes sense it would go to 100 or 300 feet.